So John Beddington said by around 2030, or let's say the middle of the century, we're going to have to produce 50% more energy, gain access to 50% more fresh water, and produce 50% more food. Sometimes it's 30% or 40%. Sometimes it's around 2030. But the take-home message is we've got to work the Earth system an awful lot harder at the same time as being mindful of the impacts we're having on planetary boundaries. So as well as asking you to watch Kate's video, I also wanted you to have a quick look at a report from the Royal Society that was about sustainable energy futures, towards a low carbon future. And the UK government, or maybe UK society, if you subscribe to the idea that the government is reflecting society's beliefs or wishes, is committing itself to an 80% reduction in UK greenhouse gas emissions by 2050. So there was an important piece of legislation put in place in 2008, and that kind of set sort of national targets for the reduction in greenhouse gases, so CO2, but methane and other things that we're going to do to affect the relative balance of the Earth's climate. So 4% reduction a year, well, you can use the rule of 72, so that means in about 18 years we should be looking at a 50% reduction. So by 2027, the amount of carbon dioxide that the UK is emitting should be about 50% of 2009 levels. Right, so let's look at the trend last 20 years or so of total emissions, and it's colour-coded by different sectors where those emissions are coming from. And, well, if you regress that line, if you kind of fit a straight line to it, it is kind of down, but not a great deal. There's a significant reduction around here. I mean, do you know why? Does anybody know why emissions kind of significantly went down around 2008, 2009? Any guesses? Yes?
Is it just the impact of the global financial crisis and people going out of business?
Yeah, it was the unfolding global financial crisis that impacted the UK economy, that put the UK economy significantly into a recession, did a good job of reducing our CO2 emissions. But you can see it kind of bounced up and then went back down again. If you've been watching the news, you'll see that the UK is slowly clawing itself out of a recession. It's slowly producing positive growth, yes.
Is that graph globally or just the UK?
So that's just United Kingdom emissions. So this impossible to see URL, which will be on the lecture slides, is where I got that from. So that goes back the last 20 years or so. So if you compare 2009, so 2009 is this baseline emission with where we are right now, then, well, from last year, our emissions have actually gone up. So from 2011 to 2012, emissions went up by nearly 4% rather than going down by 4%. So why is that? Why can't we just sort it out and undertake sustained long-term reductions in the amount of carbon dioxide that we emit? Why can't we transition to this more sustainable future that everyone seems to be talking about? Well, it's about pollution, and it's about this thing that I'm calling externalities. This doesn't look very nice. It's an oil spill in Sudan. Wouldn't want to live there. And it's a form of externality in that someone's come along and either through the pumping or extraction or transport of crude oil, they've made a bit of a mess. Didn't mean to make a mess. Maybe it was an accident. Maybe it was just poor policy or guidelines. Someone was sloppy. But this is an example of point pollution. This is another example of point pollution. Now, again, you might not want to go on holiday here, but this area around the banks, I mean, it looks inhabitable. I mean, there's a factory on it. But this is arguably having a much, much larger impact. Because what's happening, this factory here is discharging untreated effluent, the kind of byproducts of the manufacturing industrial processes, and it's flowing into that river. And once it gets into that river, the river then advects away that pollution. It takes it away. And we can begin to think about this in terms of simple little representations of system dynamics. So you've got some kind of factory, it produces some kind of pollution, and it ends up in a river. And the great thing about rivers, because they are large bodies of water, they can pick up a significant amount of pollution, and they can just transport it away. It literally becomes somebody else's problem. And we can donate it as a cloud. So there's some kind of sink here, There's a source of maybe pollution, maybe there's a source of natural pollutants into some kind of stock of pollution. And the factory is making, let's say it's making a significant increase in the flow of pollutants into that stock. And there's a constant flow of pollutants out of that stock. Eventually, those pollutants get absorbed somewhere. And from the factory's point of view, that's kind of like a sink. And we can put a cloud in it because we can say, by denoting it with a cloud, we're not really interested in the details of it. We don't want to understand the mechanisms or processes. We just know that if we input something into that pollution stock, it goes away, it disappears somewhere. And it could be the case that the factory is actually the only real appreciable source of pollution into that stock. So that's an example of an externality. The people who make the things in the factory are not doing that in order to increase pollution in the stock, but it's a consequence, it's a byproduct of their activities. So these things called externalities are important in the context of the global challenges and also in terms of the perfect storm. And there's lots of examples of externalities. In fact, pretty much everything that we do has an externality. An externality is simply an impact or effect you have on someone else as a consequence of your behaviour when you didn't mean that consequence to take effect. We didn't mean to interact with somebody like this. We didn't mean to make them sad or happy. Because externalities can be beneficial, and they can also be negative. They can be good or bad. So the people who introduced cane toads into Australia in order to eat cane beetles didn't want to decimate the indigenous flora and fauna. They didn't want the cane toads to take over significant proportions of Australia, but they did as an inadvertent byproduct. So, going back to a kind of point pollution example, so here we've got a factory, and that has some kind of input into a stock of pollutants. So here we've got some kind of, there's a body of fresh water, if it's a lake or a river or something, and over time, because this factory is, as a byproduct of its manufacturing processes, it's discharging waste into a river, and it kind of builds up into the freshwater stock. It can build up to such levels that it starts to have a negative impact on something, has a negative impact on the ecologies or the ecosystems that live within that body of fresh water. So it may decimate fish populations. It may decimate fish populations, and therefore it has a negative impact on the small communities that live around that body of fresh water who would otherwise catch the fish in order to eat it or sell it at market. And this is a classic example of an externality because we can follow the causal chain, the feedback loop, right up to this point, but then there's no real impact from the people who are being affected by the pollution on the system which is producing the pollution. There's no feedback loop there. There's an absence of any feedback that the polluter has on their impact on the environment. It's a classic externality. And this is another one. So it could be small scale, it can be regional scale, we're talking about carbon dioxide. So this is the Aral Sea, which in a few decades went from being the world's 4th largest freshwater lake to a series of much, much smaller, impoverished lakes. Why did the Aral Sea evaporate away? Because the rivers that were flowing into it were diverted for irrigation purposes. And they were irrigating things like cotton or other cash crops. So some people made an awful lot of money. And those people who made an awful lot of money, the reason they wanted to divert the water, the reason they wanted to irrigate the crops is because, I don't know, whatever reason you want a lot of money. Bigger house, nicer car, whatever, maybe just like counting money. They didn't want the Aral Sea to disappear. So when the Aral Sea evaporated, so did the fishing communities that had grown up along its borders. So that's another example of an externality. Now, some externalities can be relatively easy to fix. So we can look at examples where collectively, maybe even at a global level, we've somehow got our act together and we've sorted out. So Claire Saunders talked about this example. This was the problem of the accumulation of CFCs in the Earth's atmosphere. So as a consequence of manufacturing items like propellants or refrigerants, they use chlorofluorocarbons, which are really nice molecules, and it was thought that they were relatively inert. people were detecting CFCs. Jim Lovelock invented the electron capture device, which was the first instrument which detected CFCs in the Earth's atmosphere. Very, very low concentrations, but the CFCs were being produced on the other side of the world. So that was the first indication that a byproduct of our industrial processes was releasing these molecules into the Earth's atmosphere. And at the time, Jim and other people thought there wasn't anything to worry about CFCs. He called it one of his greatest blunders because he didn't know, and lots of other people didn't know, that whilst they might be relatively inert, if they migrate up to the top portions of the Earth's atmosphere, they react with sunlight. The CFC molecule gets split apart and it combines with ozone, and therefore it produces the thing which we all know is called the ozone hole, or rather the thinning of the ozone layer. Why is that a problem? Well, the ozone layer is a very important shield from some of the more harmful elements of solar radiation. So, as that shield gets decreased by an increase of CFCs, then there's going to be a direct impact on human health. You'd imagine, or there would be significant increases in the number of skin cancers, let's say, or eye diseases. And not to mention there'll be impacts on other species as well. So it's very bad. But in the example of CFCs, there was a clear kind of causal relationship between the people who are being affected by this problem and the organizations or entities or corporations that were at the root cause. Because the people who were going to be affected were people in Australia, people in Northern Europe, people in Northern America. The citizens of those countries maybe sometimes even worked for the corporations that were producing the pollutants. So these people here, unlike the people who are subsistence fishermen in a lake in which the lake is being destroyed by industrial processes, these people here, they have a voice. They have a democratic voice, they have some kind of democratic representation. They can vote for people who would enact legislation to reduce the point pollution. They have economic power, they can begin to boycott or preferentially buy things that don't include CFCs. So this element here, the fact that there was a causal relationship between the impact on humans and the point of the pollution, was an important reason why collectively the global community produced the Montreal Accord and effectively solved, or at least ongoing processes to solve, the thinning of the ozone layer. So that was the example that Claire talked about in the terms or in the context of global governance. Situation is different with carbon dioxide. So once again, we've got some kind of processes. An important difference is previously CFCs were manufactured in fridges and your underarm deodorant propellant or something, whereas CO2 gets pretty much produced at any stage in our industrial economies. That has a negative impact on the Earth's climate. It increases the greenhouse effect, it increases the radiative forcing of the Earth's climate, therefore it's making it warmer. But what are the impacts on people? Well, there are already some climate change refugees. There are some people who cannot live in the places that they have historically lived in because those places are now underwater because of sea level rise. And there are lots of predictions for how different people or different peoples on a global scale will be impacted through change in the Earth's climate. But as far as we go, well, what kind of impacts are we experiencing as a consequence of a change in the Earth's climate? So there's lots of discussion right now along the subject of to what extent is the freakish kind of weather we're getting in the UK a consequence of climate change. So the Somerset levels is now turned into a significant inland sea. There's been significant flooding. Since the start of the year, I think some places have seen maybe 70 or even 80% of total annual rainfall in just these few months. But does it really impact us? Does it have an effect? Are we suitably motivated to then go and actually do something about it? The switch from CFCs to other alternatives was, in some contexts, a incentive, an opportunity, a business opportunity, because you can differentiate your product with, the greener CFC, the product that doesn't contain CFCs. And although we do have opportunities for using products or services which somehow have a smaller environmental impact because they use energy more efficiently, it's very hard at an individual level to decide to somehow opt out of the system which is responsible for the creation of carbon dioxide. The emissions of CO2 is just enmeshed into pretty much everything that we do. It's very hard to extract yourself from that CO2 producing system. So that's individually. Also, at the level of a corporation or an organization and a country, there's the problem of coordination with something that we talked about in class in terms of this thing that I call the prisoner's dilemma. So these might be individuals, there may be corporations, there may be countries, and there's enough money in the world, there's enough resources in the world, there's sufficient technology in the world for us to not have any deleterious impacts on the Earth's climate. We could transition to, let's say, a solar future, where we generate all our electricity via solar power. It's not easy, but it's not impossible. But the problem is one of a coordination problem, because we need to get all these resources somehow into some kind of collective pot. To somehow, individuals or corporations or countries have to contribute to collective actions to solve these global scale challenges. And if we can, and when we ran these kind of climate change games with you in class, many of you actually could. And one of the motivations we wanted to conduct that experiment was to see how your ability to coordinate and come up with sufficient funds can be changed in the light of different kind of incentives. So for example, you've got to pay for insurance or something. So I hope on Friday to present the results of that. I can say now that in a way you're not a very good group to run experiments on this, because even though I told you to act like selfish, self-interested actors, some of you couldn't help being altruistic or somehow being interested in the outcomes of the game. So you kind of skewed the results. But in and of itself, I think that's quite interesting still. Anyway, when you've got situations like this, you've got this kind of prisoner's dilemma, do you cooperate or do you cheat or default? If you can coordinate and solve that coordination problem, then everyone's happy. But there is always the temptation for someone to hold on to their money and be happier than everybody else. So problems fixed, that's great. I also can keep hold of my big stack of cash. So I've talked about externalities, I've talked about money, and this picture is pretty much central. So, economists, what's this picture? Who wants to tell me what this is a picture of? Anyone? I suppose it's a mechanism for growing GDP. It is the coupled system or the coupled economy. Yes, are you going to say something?
Oh, is this circular flow?
Yes. So it's the coupled system, it's the circular flow of goods and services and money or stuff around an economy. So you've got households, I guess that's us, and we buy things, we buy products and services, and those products and services get made in firms, and those firms employ us and give us wages. Also, we can tax their profits, and they can give out share dividends. And so there's a kind of flow of the more goods and services that firms can make, the more things that we can buy, therefore they'll have more profits, which they can then reinvest into more manufacturing capabilities, a faster kind of iPad or a faster kind of iPhone, which we'll then want to buy. And it's a circular process, but it's a circular process with important signs of interactions. And when it's going well, those signs are positive. So the more things that we can buy, the more things we do buy, the more that firms can grow. And so a kind of central element in, let's say, capitalist systems like this is growth, and growth is good. Growth is good because it can outpace inflation. There's lots of other reasons why growth is good. So I asked you to watch Kate's lecture, and Kate last year gave a Global Challenges lecture, and she's been giving the same kind of message for a number of years now, and it's a relatively simple one, but it's quite subversive and a little bit naughty. She said, economics students, or maybe even if you're not an economics student, but you know someone who studies economics, find a book on macroeconomics and find this picture. And this picture, the circular flow of goods and services in the economy, will be in there, most probably towards the beginning of the book, because it's an important concept. This is an important diagram. And she said, what you should do, you should take a pen and you should draw in the fact that the circular economy is actually embedded in an environment. Later on, she modified her position. She said, don't use a pen, use a pencil. I think she got told off for promoting people to deface textbooks. But find that book and then draw in the fact that both households and firms require natural resources and they produce pollution. You need things, and ultimately you dig it up out of the ground. You need material resources, you need kind of that primary production in order to make anything. And even in a services economy, we still need energy, and we extract that energy from the environment, so we are consuming natural resources. And as a byproduct, as an externality, as a consequence of the activity of these processes, we produce pollution. So really, the circular economy is embedded in the environment, and typically we just think of it in terms of clouds. So resources come from somewhere. Now obviously that's quite important where they come from, and it affects commodity prices, etc. But you know, stuff comes from somewhere, it gets consumed or developed or molded or exploited by this process, and it gets spat out at pollution, then it just disappears. The global challenges, and in particular the perfect storm, is really a way of trying to situate and embed notions of a circular economy within a finite planet. Because there will be limits to the amount of stuff that we can consume in terms of its resources, and there will be limits in terms of the ability for natural sinks to absorb the byproducts or the pollution of our industrial processes. And this isn't a new idea at all. It's 42 years ago since Limits to Growth was published. And all this model did, really, it took the notions of a circular economy and it just embedded it in its environment. So it made explicit that cloud. It said there's a stock of something, and it called it natural resources. And it made explicit that cloud of pollution sinks. It said there's a capacity for the environment to absorb pollution. And when you have finite resources in terms of the ability to extract things and finite resources in the ability to pollute things, and you couple that up with the systems of growth, or that circular economy, then you can reach situations like this. This region that in 1972 they produced what they call this reference run, or the standardized scenario, where around 2020, 2030, maybe around the middle of this century, the system undergoes some kind of tipping point. That positive feedback process, you know, more goods and services, more money, you know, flowing around, suddenly changes sign with an interaction with other biophysical properties, and what was previously positive feedback in terms of growth can suddenly become positive feedback in terms of collapse. And when you've got simple models like that, then one of their motivation was to try to explore, well, how can you get out of a situation where you have runaway growth and then collapse? How can you produce what they call this stabilized scenario, where you see industrial output will increase, but then, you know, slowly increase, when birth rates and death rates will come down, when overall standards of living will, you know, smoothly increase rather than go up sharply and then collapse. And what they found, one of the takeaway messages of the book, is stabilized scenarios like this, given the kind of system that we've got, is very, very hard. In fact, later on they argue it's not impossible, but they can't really see how it would be possible. So when I ask you to read the Ehrlich and Ehrlich paper, that's coming from a tradition of skepticism, or it's not particularly optimistic outlook. And that not very optimistic outlook is based on the fact that we typically have this kind of notion of a circular economy, and somehow it's disconnected from the biophysical environment in which it must reside in. And that discussion, in some ways, hasn't really moved forward a great deal. But it has begun over the last few years, and one of the reasons it has is because we're becoming much better at quantifying planetary boundaries and identifying where we're going beyond safe thresholds and limits. And this is getting a lot of traction. Again, this isn't a new message. You know, people have been talking about this since the 1960s, maybe even since the start of the 20th century or even before. But this is getting policymakers, you know, the corporate agenda, it's making people take notice. And so when Kate developed her Oxfam donut, she basically just took the planetary boundaries concept It said, yes, we need to appropriate certain resources, we need to produce a certain amount of pollution in order that people have significant or sufficient water, income, education, resilience, etc. So these are the 11 social foundations which get embedded within the 9 planetary boundaries. And the task that we've got is somehow to make sure that people have enough, but that we don't actually go outside of this safe and just space, and so we overshoot and start degrading the environment. What's a particularly subversive aspect of this message is that when you look at it on a regional basis, you see some regions are well outside any kind of safe operating space. The amount of carbon they produce is enormous. Whereas other regions, they're not really having any impact at all, and where they are in terms of the social foundation is they don't have a very good high quality of life. So there might be a fundamental redistribution component when you're looking at the Oxfam donut. So in my humble opinion, I've been quite surprised as to how much traction this has got, both at the governmental, the UN level, in terms of corporations. Because when you think it through, if we've all got to stay within the just and sustainable space for humanity, that necessarily means that some people are going to have to consume less of the Earth's resources. The dreaded socialism, perhaps. So, circular economies, embedded in the environment, how can we collectively self-organise to, make this safe and just space? Well, we have the technology, we've got solar power, there's an awful lot of it. There's tremendous capacities for solar power on Earth, more than we'd ever need. There's lots of technological problems, but I think the sticking points are more geopolitical. So some of this was spec'd out in that report that I asked you to read, so the Royal Society Towards a Low Carbon Future. And I wanted to talk about this very briefly in the context of the critical transitions. So I've talked about critical transitions or tipping points in an almost pejorative way, they're bad. We want to be in this region over here. We want to be in the stable system. We don't want to drive the system too much because then it might fall into an undesirable state. But when we're talking about the transition to low carbon economies, then really we actually also need a kind of critical transition, because this is where we are right now. This is fossil fuel lock-in, okay? And we actually want to be over here. We want to be in a region where we can generate significant amounts of energy without producing significant amounts of carbon dioxide. But there is an energy bump here. This is all the infrastructure that we would need to build or dismantle or repurpose. This is all the kind of political associations with the carbon economy, or the economic associations with the carbon economy. So somehow we need to get from this point to this point via either this great big bump or change the landscape, change the surface. So make the solar option or other low carbon options much, much more attractive and easier to transition to. And to conclude, when we were talking about discounting risk, somebody made the point about Yosemite. Who was that? Somebody said about Yosemite is going to blow up one day anyway. That's true. If you wait long enough, there's like a super volcano under Yosemite National Park. And if you wait long enough, it will blow its top. It may blow its top in a quite catastrophic way that could produce a mass extinction event on Earth. It won't kill all life on Earth, but it could be up there in one of the big 5. So, given that there are mass extinction events, given that all life on Earth will cease one day eventually, what's the point in trying to somehow preserve the biophysical processes in some kind of pristine state, or what's the value of trying to not transition away from this thing called the Holocene, or what's the risk of really exceeding the planetary boundaries? And ultimately, if you think about planetary boundaries and the Oxfam donut, it's about quality of life. So right now, today, well, let's say every year in our current world, 1.5 million people die because they don't have access to clean water. That's on the Earth right now. So for some people, our current Earth isn't a particularly nice place in which to live. And this isn't a technological problem. We've had the technology to deliver clean water for thousands of years. It's called a well. So discussions on planetary boundaries, the Oxfam donut, and navigating the perfect storm are ultimately value judgments, they're normative judgments. What kind of a world do we want to live in? What kind of a world do we want our descendants and future generations to live in? And I think it's very important to bear that in mind. So for Friday, we're going to do some group activities. We're actually going to start on aspects of Assessment 2, but then also Assessment 3, the poster. In order to do that, I need you to read John Beddington's report. It's only 8 pages. It's a very short scientific report he produced when he was the UK Chief Scientific Officer. And then also watch a guest lecture video by Gail, who talks about the nexus or the interaction between food and energy. Okay, thank you very much.